All right. Hello, everyone. Thank you very much for coming. I'm very pleased that you came to my talk, even though that was your only option. I'm really happy to be here. I'm really happy to be in New York. So last year we were in Sunnyvale, of course, which really pales in comparison as a conference location. You can construe an all expenses paid trip to New York as some sort of boondoggle, whereas getting an all expenses paid trip to Sunnyvale is a bit like receiving a free all month long supply of cabbage or something. But maybe I shouldn't be so down on Sunnyvale. I mean, it's a great place to be if you want to be a defense contractor. Not that it would interest anyone in this room. All right, so I'm here from Dropbox. I'm here to talk about some of the tooling we've developed around Bazel at Dropbox. And so we're pretty big users of Bazel. We were kind of early adopters. We started using it in 2015 when it was first released. And we've been using it intensively for a few years now since then. To give you some sense of how we've gotten into Bazel. Just last week, someone was telling me about how great it is to configure their C++ actions with cross tools. And so if you know anything about cross tools, you know that we have really drunk the Bazel Kool-Aid, or we're just twisted. But we really like what Bazel has given us. And one of the reasons is we force all of our server software to be built with Bazel. Everyone has to use it, whether they like it or not. Most of them do like it. Recent survey, we asked developers what their favorite developer tools were, and Bazel turned out to be the second most loved developer tool. Sometimes I think the correct order or correct title here would be second least hated developer tool, especially since number one was hard liquor. But you know, it's a philosophy of mine that if you can't give developers tools that they love, you should at least give developers tools that they find pretty okay, or allow them to reach dissociative states where they find everything pretty okay. So we'll take what we'll get. And when we were converting our code base to Bazel, we started writing a huge amount of build files. And so currently we have 52 megabytes of build files in our main repository, which is kind of a lot. And we had a lot of code even when we started our conversion. And when we were doing the conversion, we found manually writing build files to be error-prone and time-consuming and boring work for humans to do. So one of our engineers wrote a build file generator, which was enormously useful in doing our initial migration to Bazel, and such that we integrated it into our build workflow. So this talk is about our build file generator. But before I introduce you to specifically our build file generator, I need to tell you a little bit more about our tooling around Bazel. So most of our tooling, build tooling, goes through a tool called BZL. So we're not very creative at naming, so we just took Bazel and dropped the vowels from it to create a new name. Most people say BZL to refer to this tool. If you're not American, you're allowed to say BZL. Some people try to pronounce the entire word by saying Bizzle, but I think it sounds like an infectious disease or some sort of stinging insect, so I'm going to stick with BZL. And BZL has a bunch of functionality and subcommands. Probably the most basic is that it wraps Bazel. So if you call BZL with a subcommand that is the same as a Bazel command, like build or test or run, then we just shell out to Bazel and execute that and let Bazel handle it. And the reason for this is that it provides consistency to our developers. Developers don't have to know whether BZL or Bazel implements the functionality they're looking for. And it allows us to do some light wrapping of Bazel. So we can do system checking to make sure the development environment is set up correctly, and also some logging so we can keep track of what our developers are doing. Something more interesting that BZL does is a subcommand called itest. So itest is capable of setting up a complex integration environment full of services which have various dependencies between themselves, and bringing it up reliably. And so this is how our developers write complicated integration tests and also do development. And in fact, this is a talk of its own, which we gave last year at BazelCon. So I refer you to that talk if you want to learn more about BZL iTest. What we're interested in today is a subcommand called gen. So BZL gen is a multi-purpose build file generator. It supports generating build files for all of our most commonly used languages. And I'm going to show it to you how it works with over a series of examples. So the first language I want to talk about generating build files for is Go. And of course, there's prior and open source art about this, including Gazelle. But we have a little bit of a different take on this, as you'll see. But the first thing to say about generating build files for Go is that the Go built-in native language tooling of Go is pretty good already. So most of it is mediated through a tool called Go, which has build and test subcommands like Bazel, and actually works quite a bit like Bazel out of the box. And a lot of this happens because Go has very strong conventions about how code should be laid out. So the basic unit of organization in Go is a Go package, which is simply a set of Go files in a directory. And if you want one package to depend on another, you just write an import statement which imports that package directory's file system path. And because of these very strong and simple conventions, the Go tool is able to do its work building and testing without any extra metadata like a build file. So because of this simplicity, if you take a person who's been developing Go for a while, they're going to be pretty resistant to having to write a build file because they're used to just having this all inferred by the Go tool. Some people will tell you that their writing a build file interferes with their Go routine. So we don't want to do that. So generating build files for Go is a very attractive target, both because of the simplicity and because of the ability to ease the migration to Bazel for Go programmers. So I have a little example of how to generate Go. And since all the cool kids these days are writing their mission-critical applications in Go, I decided to write a nuclear missile launcher in Go. So here it is. We're not actually too interested in the imperative part of my nuclear button. Basically, it opens a targets file, which has a bunch of target cities in it. It reads it, and then it opens a missile silo and sends them to their death. What we're interested in, and so is the build file generator, is the import statement at the top of this file. So there's 4 imports. 3 of them are from the Go standard library, and one of them is of a missile silo, which we're assuming is another package that I wrote to store my weapons. So let's generate a build file for this. To do that, I use BZL gen. And I just pass it the package that I want to generate a build file for. So the thing you'll notice is that BZL gen is a well-behaved Unix tool and does not emit any output when it is successful. But if we go look at nuclear button/build, we'll see that this rule has been produced. So throughout, I'm going to be using the Dropbox version of rules, so ones which are prefixed with DBX, simply because that's what our tool works with. But they're very similar to the open source versions of rules and also the general Bazel principles. So sources and depths do not do strange, unexpected things here. But you can see that the build file generator has figured out this is a binary target, so we need to generate a binary because it's main. It's put the sources in the right place, and it's collected the dependencies out of the import statement and turned them into Bazel dependencies. So you can see that literally everything in this build file is inferable from the source, which gives you some idea why some Go programmers are frustrated with having to write these things manually. So now we need to check that this works, right? So I'm going to press my nuclear button here with Bazel run, and I prepared a targets list. I'm not going to tell you what's in there, but let's fire this thing up and hit enter. Ah! A skyframe of val error? Ah, caramba! Ah. Okay. Well. I mean, Bazel, like certain world leaders, knows its alpha status and sometimes acts unstable. But maybe we can try to figure out what's going on here at least. Okay, so we have some sort of like nested cause illegal argument state exception, and actually, it's a Java traceback, so this goes on and on, almost there. But then finally we find that the JVM can apparently raise a nuclear holocaust illegal state exception, but I guess it's kind of saved us from our worst impulses yet again. All right, so we didn't actually manage to run my Go program, but we did generate a build file for it, and it built. No, it didn't. But so I'm going to check that off our list. Let's talk about Python. I did not want to write more components of the national defense in Python. To me, Python is a much more ironic language, Zen. So I fell back on a computer science mainstay, namely Hello World, for example purposes. But I didn't want you to think I was too much of a horrid curmudgeon, so I implemented it using TensorFlow. So here we go. Say hello. So once again, we're not really so interested in what's actually being executed here. Basically, it takes your name in as a first argument, and then it runs my sophisticated neural model. And then you can even print things in TensorFlow. So I took care of that with TensorFlow. But once again, what we're interested in, and what the build file generator is interested in, is these imports at the top. So you can see there's a standard library import, sys, and then there's an import of a global constants module, which we're going to assume is kind of in a different package, and a local relative import of a model.py file, which is in the same packages as say hello. And then finally, there's a couple third-party imports to run my model. So Python is a little more tricky to generate build files for than Go. There's not really the same kind of strong convention as Go in terms of source code layout. So we need to provide some hints to the generator as to what kind of build file we're expecting to get. And the way we do that is we write a kind of template build file, which for our build file generator is called build.bzl. So if I want to make a build file for this, first I have to write a build.bzl file with a little bit of information about what I'm expecting to get. So I want to have a binary, which actually is my program, and then I also had my model, if you'll remember. So that's going to be in a separate library. So I write the rules that I'm expecting to get, their names, and their source files. But I'm not going to write any of the dependencies because that's what I'm going to let BZLGen actually generate for me. So if I go and run BZLGen on //hol, it'll go and look at this build file, and then it will go and generate the dependencies and fill them in my build file of the template. So you can see the local model import has been turned into a colon import of this library down here. And we have a correct dependency on // global constants. And furthermore, the third-party imports have been handled by redirecting them into this // pip namespace. So we have a convention at Dropbox that all of our third-party Python code goes in // pip. And our build file generator is aware of that and can handle third-party code by redirecting imports in that way. OK, so now we have a build file, so we need to test whether it works or not. So let's say hello to you. BazelCon. All right, let's hit enter. OK, well, this is a pretty sophisticated hello world, so we're going to have to wait a little while my neural net runs. Just think now, as we're speaking, the computation is being farmed over thousands and thousands of TPUs before coming back to us and saying, hello, stop sign. So luckily, my neural net is not driving yet. But I'm going to check Python off our list because, once again, we managed to actually make a build file that built something, even if it didn't run anything. And the Python brought up a larger idea in BZLGen that we can write template build files where we only write the non-monotonous stuff. So you saw that with the Python build file, but this works for basically any attribute in your rule. So sometimes there's metadata which you want to include in the build graph, which isn't derivable from the source code. So common examples of that in Bazel are things like test sizes or tags. So here's an example of a Python test. So it's a test of a pie crust. The pie crust is really high quality, so I need to tag it with flaky. And so but I still want my dependencies to be automatically generated from my pie crust. So in my build.bzl file, I put the name and the main, and then also the tags and size that I want. And then when I generate this build file, I will get all the attributes that I manually specified copied over, as well as the dependencies automatically generated. Sometimes you even need to tweak automatically generated dependencies. So sometimes there's dependencies which aren't statically inferable. So this often happens when people write cute plugin systems which like concatenate together strings and then import that. So we support tweaking the automatically generated stuff while mostly getting the benefit of the statically inferable defs. And the way you do that is by specifying an additional underscore name of an attribute. So the build file generator takes that, it does its normal generation step, and then it concatenates what we originally had onto the end. So you can see in the example of mylib here, we have the normal defs, which are presumably just imports in mylib, and then finally, my magic plugin gets put on because of my additional depth specification there. We've covered Go and Python, and actually that covers most of the interesting cases, because basically if you have the ability to specify a little template in your build.bzl file, and you have some tool which can parse imports or dependencies out of your source code, you're all set to generate build files. So our build file generator also has support for other languages we use like Rust, TypeScript, Sass, and Java, and can also follow Maven deps. So I want to be very clear here. The Maven here I'm referring to is the Java package manager, not the lucrative defense drone contract. The notion of generating targets for the latter one is quite a bit more sinister than what I mean here. Right. So now that we've seen a few examples, we can discuss some of the general reasons that you would be interested in generating build files. So one I've been alluding to a while is that we don't want to be forcing people to learn new things. So the Bazel build definition language is higher level than a lot others like Make or something. Is pretty easy to pick up, but you have to remember that you and I are build engineers. We spend all our time dreaming about build files and experimental Bazel flags and all sorts of wonderful things like that. But the average engineer could not care less. They just want their code to compile and start segfaulting as soon as possible. So we cannot get in their way, right? But the larger point is, the build system is supposed to be serving the code, not the other way around, right? So we shouldn't really inflate our self-importance too much, even though we're important. So the generating build files really helps with helping people adopt Bazel without actually having to know anything at all, and so which unfortunately is a positive thing. All right. Another good thing about generating build files is that it's much more likely that your build dependency graph will actually reflect what's in your source code. So if you're manually maintaining build files, what tends to happen is that dependencies are ever growing, right? Anytime someone has a compile error because they don't have a dependency, they add a dependency. But people very rarely remove dependencies when they remove a dependency from the source code. But with a build file generator, it's very easy to immediately make the build file always reflective of the source code, which is very useful for speeding up builds because there's less CRUD, unnecessary CRUD, and things like doing Bazel queries to understand how your code base is structured and makes that much more accurate. A sort of related reason is that refactoring large amounts of code is eased by not having to manually edit build files. And there's already tools which are good at refactoring build files, like Bulldozer is an example. But I'd like to point out that using Bulldozer to do a refactoring that involves build files is a little bit of a different workflow than using something like BazelGen. So if I'm using Bulldozer, I have to make my refactoring, then kind of figure out in my head how my refactoring needs to be represented or mutate the build graph, and then come up with the Bulldozer commands to actually execute that refactoring across the build files. Whereas with BazelGen, I just move my code around, maybe change a few build.bzl templates, and then you can use a special option we have for BazelGen called reverse depth gen. And what that does is you pass it a bunch of packages which you've refactored. It generates those, and then it finds all the packages in the workspace which depend on those packages and regenerates them too. And that usually almost always takes care of fixing all the damage from a refactoring in the build graph. All right, now that we've discussed all the delightful things that build file generation gives us, I'd like to append to this talk a asterisk. And a very large purple one at that, and kind of tell you some of the ways that this can go wrong. So the first thing I'd like to say is that strong conventions are very much required in order to make this work. So conventions are the reason that Go is so easy to generate for. And even in other languages where we kind of have to provide little crutches for BazelGen in the form of build file templates, it often is still necessary to refactor your code and move it around in order to make it conform to a more standard interface. So rather than adding special cases to BazelGen, we tried as much as possible to make our code base standardized and conformed. So this was, obviously that's kind of a general good thing to do, but this was really an impetus to do that because it gave us much better tooling support. Another subtle thing is, so actually implementing this thing can get a bit tricky. So for example, to add the dependency corresponding to a Python import, I have to go find what that file, that import corresponds to, and then I have to find what target that file, that dependency file, is contained in. And so in order to do that, I actually have to go and parse a build file in my build file generator. And so this means you are kind of re-implementing some of the logic that Bazel does. And things can get extra complicated when you're generating many different kinds of rules. And some rules are just popped into existence without templates, like Go rules, while others have templates, and there's various stages of generation. And it can get quite tricky to make sure that everything is sort of deterministic and ends out in the right place. So we've had strange situations where like various parts of the tree have loops and resonances where like if you generate one part of the tree, it makes the other part of the tree like need to be generated. And if you generate that part, then the original part needs to be generated. And it can be, and to some extent, you're having to reinvent a lot of what Bazel is good at, which is incremental understanding of very large dependency graphs. So it's something which you have to keep in mind. Another false path I'd like to tell you about is generating files which aren't build files in a build file generator. Yes. So the thing about BazelGen is that it's essentially a command which can do arbitrary non-hermetic things, which is run by all of engineering constantly. Which is a very, very dangerous thing. So we're totally outside the Bazel world here, and we're not restrained by punny things like sandboxes or proper dependencies. And so we can do whatever we want, and so obviously people do whatever they want. And one of the things people really want to do is hook up their code generation into BazelGen. And I'm going to discuss one example of a proposal to do this, and it revolves around Go generics. Yes. So if you know anything about Go, you program in Go, or you read Hacker News, you'll know that Go does not have generics, and so. This means if you want to implement a container type which can hold several different kinds of values, you're generally faced with one of two bad options. Number one, you can copy your code every time you want to change the type in it and sort of like search replace. Or number two, you can make your container type use a special kind of universal untype uni thing called the empty interface. And the empty interface is like emits toxic fumes and isn't type safe and like is flammable and sort of subjects you to the most stringent kind of government regulation. Although I hear the EPA is working as fast as they possibly can to provide relief there. But anyway, people don't really like to do it. And so we had a proposal at Dropbox to solve finally the problem of Go generics with BZLGen. And so let me give you an example of how this scheme would work. So let's talk about silos. So we already had a missile silo, but sometimes you want to put other things in silos, like I want to put corn in a silo. Other things you may want to put in silos include app ecosystems, people's news feeds, but I'm going to put corn in. So the proposal that we were looking at involved doing something like this. So if you want to have a corn silo, you would go and write a build.bzl file in your corn silo package. And it would have this special dictionary called Go generic instantiations. And you see it has a corn silo key, and that has a template source. So maybe you can see where this is going. And the template source is something called generic silo.silo.go. And then there's some type parameters. So the value is going to be corn instead. So what would happen is if you went and you ran BZLGen corn silo, then if we looked at the content of generic silo, we would see that what ended up in corn silo was just filled. The value was replaced with corn as we had specified in the build file. Great, so Go generics are solved. So I bring this point up not to make fun of Go. Well, I bring this point up not only to make fun of Go, but to say that from a build systems perspective, what you should be doing is writing a rule to generate your Go generics. Right? So it's an eminently possible and rather easy to write a rule that takes an input file, a template, applies some substitutions to it, and emits an output file. So I sketched up an advanced example of how you do this. You'd have your dbx go generics rule, which took the template, the generic silo, emitted an output, and then the substitution dictionary has just been moved to Skylark, right? So from a build systems perspective, this is A-OK. Hermetic goo goes in, something happens, hermetic goo comes out, which is a deterministic function of the input goo. So we're all set from a build systems perspective, and we don't have to make our build file generator figure this out, and we can leave it to the Go people to debate the ethics and morality of this thing. But I'm afraid we did not accept the Go generics thing. But we did kind of go down this road hard. So we currently are generating all sorts of things with BZLGen, proto-seed, RPC stubs, database schemas, tests, metrics, and more RPC stuff, and build files, which are roll-ups of other build files. And so it's kind of nasty. So don't do that. One last word of advice. Do not use your build file generator to override Bazel's default and perfectly reasonable private visibility. So as you may know, targets in Bazel are private by default, which makes sense. And early in our Bazel migration, we decided to expedite the process by having our build file slap a package. Default visibility equals visibility public at the top of every generated build file. And that eventually we realized that this was not a good plan, but fixing this was just a ginormous tragedy, a tragedy worthy of Sophocles or Shakespeare. So what we ended up having to do is grandfather all existing build files into public visibility and putting a comment which says, this file is grandfathered into public visibility because the build infra team is idiots. Please do not copy this. And maybe you can imagine what happened. So now every time someone creates a build file, they carefully copy the public visibility thing, along with a comment which says, "Do not copy. Build infra is idiots." And it just makes me so sad. The only thing which makes me feel slightly better is being in company with misery. So if you, back in 2016, Google published this paper about how they have a gazillion lines of code. And there was a sentence in there: a lesson learned from Google's experience with large monolithic repositories is that privacy by default should be put in place as soon as possible to encourage more hygienic dependency structures. I interpret this to mean Google had the same problem. With that final note, I'd like to briefly thank some of the people who made this possible. So BazelGen was originally written by an engineer called Patrick Lee. He came up with many of the foundational ideas of BazelGen, and is now maintained by Dropbox developer infrastructure, of which I am only one member. And with that, I will yield the floor to your inquiries.